Hey everyone, I'm Jordan, and this is your Belmont Math Science Center tutor tip. So my tip is a little bit less specific to a particular type of math that you can do. It's actually about a tool that I really like that's been super helpful to me in both my math classes and actually in some math research projects that I've done as well. So it is called Desmos, and it's a graphing calculator online, but there's a lot of really cool stuff that you can do with it that might be a little more powerful than just what your normal graphing calculator can do. So the URL that you're going to go to is desmos.com/calculator. And when you do that, it's going to bring this up. Now, I have an account with Desmos. It's completely free to have one, and if you have one up here, once you start making anything in the graph, you can click save and name your graph, and so you can save any really important graphs that you may have, and also it comes with some really cool examples built in of graphs that Desmos has already made for you so that you can see some of its functionality. But we're going to talk about that today, so I'll show you some of that. So the first thing that is useful is just it can graph. So say for instance you're in pre-calc or something like that and you're learning about trig functions, you can just graph the sine function. Now, one thing that's kind of cool about that is that you may learn that sine functions can have things associated with them like amplitude and frequency and phase shift and all those kinds of things. So what I can do is I can put in all these extra parameters, and at first it won't want to graph it, but there's this option down here that says add slider. So I'm going to click all, and what that's going to do is it's going to bring up these sliders with all these different adjustments that I can make. So if I slide this one, you can see that that's changing the amplitude of the sine wave, how big up and down it is, and that's because it's changing that value of A. Similarly, if I slide B, that's going to change the frequency of the wave, and changing C or D is just going to shift how far up or down and left and right it's moving. And that's really cool on its own. It sort of lets you get a really good feel for what things like amplitude and phase shift and frequency are doing for sine waves. But one thing that's also super cool about Desmos that's been particularly useful for me is the ability to make sort of simple animations in it, because these sliders are actually able to be toggled on and off so that they will just slide for you. So you can just click play on this and it will start sliding that slider back and forth. And there's a few different modes that you can have associated with this. If you click on these little arrows down here, you can change how fast the animation goes. So if you want it to be going really fast, you can do that. You can also make it continue past where it started and keep going, as in, well, actually, you can tell that one a little bit better if I do it with one of the ones that moves it up and down. So in this mode, it's just going to hit the top and bounce back down. If I change it to be in this mode, once it hits the top, it's going to loop right back around to the bottom and keep going. So there are a couple cool different adjustments you can make to the animation style in particular. So this is just a little bit of a toy example, but I also have made some really neat stuff in here. So one example is this thing called Lissajous curves, and what those are is they're curves that you get by watching what happens when you roll 2 points around a circle. So I'm going to set this to this mode of bouncing back and forth and play it on 0.75x. And you can see as these 2 points roll around the circle, they trace out this point, and you can graph that process in Desmos. Now you can see it's lagging a little bit, and that's because this is calculating a lot of different stuff all at once. But it does work super well, and it lets you really get a good feel for some of these more complicated curves that you might want to graph. Another example, just a little more on the artistic side, is this graph that I have aptly named Fancy Thingy. And there's some technical stuff in here. Desmos does support lists of numbers as well, so if you want k to take on all values in a certain range, you can use this list syntax and it will do that. And then everything that you plot down here will use all the different values of k at once. But this one I use a slider as well, and you can see that I have this sort of curve made up of these interleaved straight lines. But if I up this, it ups how many lines it's using, and that makes it look more and more like a curve. And this thing right here is just what the actual curve is that it's approximating. You can see the curve if I get rid of all of the lines, and then in there, if I bring the lines back, you can't really see the curve because these lines so well approximate it that it sort of disappears. But you can make cool artistic things like this. You can make any sort of graph that you would ever be interested in. And actually, I used it for a research project between my sophomore and junior years as well. We were doing this thing where we had to graph a lot of regions in the plane, and this photo actually appears in the poster summarizing the research that I did. So it's not just useful for pre-calculus and your different Belmont classes, it's also actually super useful even at more research levels of mathematics. So I really like this tool. I think it's super helpful for any class that you might need, and I hope it helps you. Thanks.